Hey, hello everyone. So today we'll be solving converted sorted array to binary search tree question. So you are given an integer array which is actually sorted in ascending order, and you have to convert it into a height balance binary search tree. Now, what is height balance binary search tree? We are given that the a tree is height balance binary search tree if the depth of the two subtrees or every node never differs by more than one. So let's see an example here. For example, suppose there is this tree. Okay. Now, what it meant by here, height balance is every subtree, left subtree or right subtree at every node, the difference of the height or the depth should not be greater than one. For example, there is a subtree, left subtree starting at 2 is like this, these two subtree. So their difference should not be their depth difference should not be greater than one. Okay. So for example, for 5 there are these two subtrees. The height is one for the left, one for the right. So it's a equal. So it's a less than one. So these two, if we talk about this tree at 2 or 5, so they are height balanced. Now let's say if we talk about tree at 1, so there are two subtrees here. There's one this subtree and there's this subtree. Okay. So the depth of left subtree is 2, okay, and the depth of right subtree is 2. So again, difference is less than 1. So again, this is a height balance. If we talk about another example, let's say there is a tree 1, there is a tree 2, there is a tree 3. Okay. Uh, so yeah, that's let's take this example. So if we come here for 2, we see that the subtree at the left side is of depth 1 and the right side is 0. So for this tree, difference is less than equal to 1, so that's correct. So tree at node 2 is height balance. But if we talk about subtree, if we talk about the subtree at root 1, we see that there is a this subtree, and of course there is this subtree have a depth 0. So the left subtree has a depth of 2 and the right subtree has a depth of 0. So their difference is greater than 1. So it means it's not a height balanced. Okay. So that's what height balance actually meant. Uh, so we are given a sorted array and we have to basically return an output which is nothing but a representation of a tree. So let's see the idea behind the solution. So the idea behind the solution is you can assume that there's this line, increasing line, which have multiple points, input points here. Now we have to, balance it. We have to somehow convert this straight line into some format or some form where it's get balanced. So what can we do is one of the approaches where we can try to break it from in between. Okay, and we can convert it into something like this. Like two parts here, so this part can become like here. Okay, so let's say different points here. Now let's say it also have multiple points here, so let's say we have to balance this part. How we are going to do is we try to break it from in between, so it will be something like this. So let's say there is this node here, and now there is two nodes here, I mean two lines here, and there is this big line here. Okay. Now similarly, we can do the same case for this line here as well. We try to break it in between. So what it can be done is something like this. Okay. And then again, it can be something like this. So we are basically trying to bend this part here. Okay. So that's what we are doing. Again, we can do that for this portion, this portion, this portion as well until we get a terminal condition. So terminal condition can be, there's only one node left, which will be a leaf node. At that point we can stop this breaking logic. So that's the idea about the solution. So let's try to solve the solution, and let's see the code first. So here's the code. We are given a sorted array, and we have to return a tree node here. So tree node is a representation of a binary tree node here. Each have a value left, right, and value, and then uh, constructors here. So we'll be returning root of the tree. So what I did is basically we have to, we created a util function, and we have passed the array, and we have to pass the start and the end index of this array. Okay, so let's understood this portion of the code here, what it actually doing. So this portion of code is doing nothing but breaking the array uh, from the mid, and it's creating a node with a mid, and then it's basically subsequently creating the left subtree and right subtree with the left part subarray and the left right part subarray. Okay, here's the terminal condition. So if and start is greater than end, that means we it's nothing, there is no node here, so we turn null here. If start is equal to end, there is only single value, so we just create a node with that value and initialize the left and right as right subtree as null. So let's take an example. Let's take this as the array. So the start here will be 0 and length will be equal to 4. Okay, so this will be passed into this function, and here mid will becomes 0 plus 4 by 2, it comes 2, so it will be 0. So we'll create a one node with value 0. Okay, now the left subtree will be created from the value start to mid minus 1. So start to mid minus 1 for left is minus 10 minus 3, and for right node it would be mid plus 1, that is from 5 to 9. So let's say in next iteration we came across this. Here the start is 0 and is 1. So 0 plus 1 by 2 will be 0. So we're creating a left node here with value minus 10, and for right we will be creating a value with 5. Okay. Now after creating left here, we after creating the left node from this subarray, now we are left with minus 3, because we are actually creating from mid plus 1 to end. So mid 1 initially 0. So mid plus 1 be minus 3, and end will be so mid plus 1 be 1, and end will be 1. Similarly, this case mid plus 1 will be 4, and end will be 4 as well. So in next iteration, if we see, we'll create this. We come to this condition start equal to end. We create a node and we return it. So for this minus 3, we'll be returning a right node here. Okay, because left is already 0 and 0 it become minus 1. Okay, so left will become null, and right will become minus 3 here. Similar is the case of 5, it will become 9 here. Okay, and finally we are returning the node here, so we'll return this node here. Okay, so that's pretty straightforward. Okay, so from this example the output is given like this, but it can also have a this as well. This is also a valid output. So I hope you have followed the question as well as solution. Do let me know if you want me to solve any other particular question. Till then, bye bye, take care.